Ladies and gentlemen, boys and girls, welcome again to our Looking Up event for February of 2022. Yes, it's already February, and if you don't know, Valentine's Day is in a couple of days. Yes, we will be looking up at a waxing gibbous moon and maybe even seeing a conjunction of Venus and Mars and a conjunction of the moon, Mars, and Venus. But not tonight. Here in Western New York, we have cloudy skies and snow. It happens this time of year, so we don't have any live views for you this evening, but we do have some outstanding presentations. This evening, we have Holly Cohen with us. We have Paul Moretti. We have Dan Marcus. We have Emily Ann Kerr, and we are going to put on an outstanding presentation for you. And to kick us off this evening, to help us help you keep looking up, is our only professional astronomer. Yes, you heard me right. The professional astronomer from the Buffalo Museum of Science, Holly Cohen. So without further ado, Holly, why don't you go ahead and take it away?
All right, thank you very much, Dennis, for that wonderful introduction. Folks, do not let the title fool you. Yes, astronomy is in my job, but pretty much everything I have learned about astronomy, I've learned from the wonderful folks at the BAA. And if you're interested, they're happy to teach you too. So I wanted to share something that has kind of been stuck in my mind the past couple of weeks. Of course, this week in Western New York has been a little bit more mild weather-wise, but we've been in some really crazy, cold, snowy winter temperatures. And it's kind of interesting the way that that can shape astronomy. So I'm definitely a person who prefers the warm. It's a lot harder to go out and stargaze and stand in front of a telescope when it's, 10 or 5 or -2 degrees out. But there are people who do this all year round and especially will travel to some of the most extreme places on Earth to do so. So what I'm showing you here is a science base erected at, I believe this is Shackleton Glacier on the icy, mysterious continent of Antarctica. So there are scientists who come during the sunny months of Antarctica's weather, where there's, mostly 24-hour sun, hopefully no 24-hour dark, and they come to do some astronomical research. So I'm gonna forward here. No, trying to advance. Let's see. How about this? Hey, there we go. So everybody, believe it or not, you can absolutely find meteorites on the continent of Antarctica. In fact, it is where we find most of the meteorites that are available for research. Out of all of the meteorites that have ever been found and cataloged and given to science collections, over 60% of those meteorites have been found in Antarctica. These meteorites number in the thousands, somewhere around 42,000 that have been found on this continent. And it's not necessarily because Antarctica is a magnet for space rocks. Actually, it kind of has to do with the continuously permanently icy surface of the continent. And this is the diagram that I'm showing you here. Of course, space dust and rocks and pebbles fall to Earth by thousands of pounds every day, every week, every year. But Antarctica is really good at catching them. What happens is our meteorites will fall to Earth, and of course, they're coming in very, very fast and very hot from making it through Earth's atmosphere. They land on the snow in Antarctica, and they do sort of melt through the ice of the permanent glaciers on the surface. The thing is, though, glaciers do move. They move slowly, but they do move. So these glaciers will, over time, collect meteorites and start slowly flowing. You kind of have these arrows here to show you your direction. Now, as glaciers move, especially by nice tall mountain ranges in Antarctica, this flowing ice will kind of transport the meteorites, while at the same time, wind erosion from the surface is going to start to wear away some of that top layer of ice. And all of these meteorites end up at what's called a stranding surface. And it's basically a nice, big, rich top layer of ice where you can find lots of meteorites. So there is a coalition from the National Science Foundation called ANSMET, the Antarctic Search for Meteorites. We have crews come down there and their entire job while they're in Antarctica is to search for meteorites. So here is a little bit of documentation going on. Of course, this crew has found what they believe is a meteorite on the ground. Now, what they're going to do is not touch it, even with gloved hands, definitely not with their hands, because the cold temperatures of Antarctica will preserve a lot of minerals, dust grains, and even gases inside the meteorite. And we want to keep those very cold and very clean to study later on, so we can learn even more about the ancient solar system or how even Earth formed than we can from regular meteorites that may fall in a warmer climate and may get picked up by people with, well, bare hands. So it's very important that all of these scientists, part of ANSNet, who find a rock that they believe is a meteorite, catalog these, the exact GPS location where they found it, and then they bag them up very, very securely. And here we've got a little bit more footage. So this scientist is actually using what's called a hand lens. Any other geologists are very familiar with this, a little tiny handheld magnifying lens, to double check without touching this rock that it may be a meteorite. And of course, Dennis is our meteorite expert here at the BIA. He can tell you a lot more about what may or may not give away a rock being a meteorite. So I'm sure he'll probably have something to show you, because if I know Dennis, he's always got a meteorite on hand. So of course, you can find lots of meteorites and very other mysterious sites on Antarctica. Of course, penguins, seals, sometimes people if you're very, very lucky. But did you know you can actually also find fossils? This permanently frozen wasteland has not always been permanently frozen. The thing about Antarctica, though, that is so special, and the reason that the South Pole and all of the area surrounding it is considered a continent versus the North Pole, is that there is ground and land and rock underneath all that ice. Versus at the North Pole, it's pretty much just polar bears, ice, and then the water under the ice. So you can actually find lots and lots of different fossils from a very, very long time ago, kind of a snapshot of Antarctica in a different world. And if this interests you and you want to come and see some of these, maybe even touch a few, then I have good news. Of course, over at the Science Museum, we're always trying to do new and extra cool stuff. And we have just opened our newest traveling temporary exhibit called Antarctic Dinosaurs. Last weekend was our opening weekend, and it's been very well received. Personally, I've walked through it a bunch of times. I love it. Antarctic Dinosaurs does not just talk about dinosaurs. It talks about other fossils, the logistics behind bringing humans to one of the most extreme places on planet Earth, and how science has to be done differently in sub-zero temperatures. And of course, dinosaurs are not the most astronomically related thing, but if you want to meet one of these Antarctic meteorites, and one of the more rare ones at that, you're going to want to come and visit this exhibit. There's a really beautiful, we'll call it a palisite meteorite, that you can go and see for yourself. And as Dennis will agree, palisites are very beautiful and very rare meteorites. So if you are interested in anything having to do with extreme environments, a little bit of environmental science, or if you just are a dinosaur fan, because who isn't, then feel free to stop by and say hi to me. Now, if you're ever wondering when is a good time to go, to make the most out of your museum visit, I would recommend coming during the President's Week break, because we will also be hosting National Engineers Week at the Science Museum. So between the days of February 20th to 26th, there will be lots of extra stuff to see and do in the museum. We will have lots of visiting guests. We'll have docents. We'll have themed activities for all ages. And if you are maybe considering a career in an engineering field, this would be a wonderful place to meet some people, ask what they do and why they love it. It's going to be a lot of fun. And if you ever want to come and say hi, you know where I'll be. Thank you very much. I'm going to send it on back to Dennis.
Oh, you're sending it back to me, Holly? I was examining a meteorite. It's unclassified, though. I was using sorry, folks. I'm sorry. I get sidetracked. Holly starts talking about meteorites and sharing all those wonderful things, and I have to go and take a look at meteorites. And, we will be returning to live events over at the Beaver Meadow Observatory come this April and May. So we will be having some live online events doing these kind of looking up things along with our public nights. So keep an eye out for doing those kinds of things as we let you know. I forgot to say hi to Tony and to Kathleen and to Steve, their Facebook Live. If anybody does have any questions, go ahead and put them in the chat here, and I'll do my best to pass them on to our panel here. And again, thank you so very much, Holly, for just a tremendous presentation. We are so blessed to have a professional astronomer here with us to help us keep looking up. And yes, we learn from each other. Science is everywhere. There is engineering, there are fossils, and meteorites kind of link over to those dinosaurs. So, you got to go take a look at those dinosaurs. And, as we help each other out to help you looking up, we also look to you to give us a little bit of a hand if you can. So if you'd like, you can check out the Buffalo Astronomical Association website and consider joining us or consider a donation. You can contact the Penn Dixie Fossil and Nature Park to go ahead and help them out. You can contact the Buffalo Museum of Science and go join them and take a look at some dinosaurs and some engineering. And of course, we already thank you for helping us out. In 2021, we had some high-speed internet installed at the observatory, and so we are able to bring you live images when we do have clear skies, of course, and we will be able to do some streaming of our online or our live events at the observatory as we do this looking up kind of stuff in a live presentation as well as online. So it'll be fantastic. So again, thank you so much for helping us do that. We're looking to return to Wilson Star Search this year, and any donations that you provide to us are very much appreciated and very helpful to us. Now, we'll be looking up in February, and a couple of our presenters couldn't normally be with us, so we have to turn to the professionals of the group. Yes, the folks over at NASA. NASA and the JPL folks have a fantastic What's Up for February, and that's coming up to you right now. So why don't you go ahead and take it away, Gene, and show us what's up.
What's up for
NASA.
February? Jupiter makes its exit, Venus at peak brightness, and the star-forming cloud next door. With the departure of Saturn and Venus over the past 2 months, Jupiter is the only bright planet left in our twilight skies in February, and it's on its way out. The giant planet stands alone low in the western sky after sunset in February. By mid-month, it's setting only about an hour after the sun. Once Jupiter departs at the end of February, the post-sunset sky will be essentially devoid of naked-eye planets until August, when Saturn will start rising in the east around sunset. There's a short period, though, in April and May when you might be able to spot Mercury as it pops briefly above the horizon. You'd have to go back 4 years to March of 2018 to find twilight skies with no bright planets. So catch Jupiter before it's gone, and look for it to become a morning planet in April. Speaking of morning skies, the planet Venus will be at its brightest for the year in February, around mid-month. It rises with Mars around 4 a.m. and is visible low in the southeast until sunrise. Venus is the brightest of all the planets in our solar system because of the highly reflective clouds that completely cover its globe. But its brightness in our skies varies depending on how far it is from Earth and on its phase. Turns out Venus is brightest not when it's closest to Earth, but when it's almost at its closest and still shows us a large bright crescent phase. So enjoy the crescent Venus, that is the planet at its brightest, and look for Venus to form a trio with the Moon and Mars on the morning of February 26th. February is a perfect time to enjoy one of the most popular and well-studied sights in the night sky, the Great Nebula in Orion. The Orion Nebula is an enormous cloud of gas and dust where thousands of stars are being born. In fact, it's the nearest large star-forming region to our solar system and around 1,500 light-years away. The bright central region of the Orion Nebula is a giant cavity in the cloud, being carved out by the intense ultraviolet light from a handful of extremely massive young stars. Finding the Orion Nebula is easy in February, as the constellation Orion will be high in the south around 8 or 9 p.m. Look for the 3 stars of the Hunter's Belt, and then find the stars that hang below it forming Orion's sword. In the center of this line of stars is one that looks kind of fuzzy. That's the nebula. It's visible to the unaided eye under relatively dark skies and is easily seen with binoculars as a faint haze. And through a telescope, it's a sight you'll never forget. Here are the phases of the moon for February. Stay up to date with all of NASA's missions to explore the solar system and beyond at nasa.gov. I'm Preston Dykes from NASA's Jet Propulsion Laboratory, and that's
was
what's
an
up for this month.
absolutely fantastic presentation by the folks at NASA. As we run through the credits here, make sure that you check out the folks at NASA and JPL at their websites. We thank them for sharing that information with us and with you. Certainly, February is an incredible month, especially for looking up at that Orion Nebula. Those are some of the things that I love to do. Now, it's still very cold here in February. And, you know, we like to spread some information about observing and looking up. Tony says, very good. And, Leilani hello from Maryland. Hi, Leilani. And it's certainly cool to meet you and everything. But, you know, in Maryland, it's also pretty cold as you're going out to look up. And with that, we have some very practical observing tips brought to you by our own Emily Ann Kerr. Emily Ann, why don't you go ahead and share us about practical winter observing?
You got it. Hello, everyone. Figured I'd do a little presentation, kind of a companion to my summer presentation. If you're a regular watcher, you know that I am usually out and about observing visually with a telescope, and I love to do it at the BAA. I love to do it at the all sorts of places all over New York. So I wanted to do a winter observing one because I have some wonderful winter objects that I love, as well as some practical winter tips. So let's proceed with that. Well, let's start off with our pros and cons. I think the biggest pro, obviously, with winter observing is that finally, the short days, it's finally good for something. It's finally worth it. We are past the winter solstice, obviously. So we're actually, days are starting to get a little bit longer here, but don't worry about that. You still have some wonderful, great nighttime hours to get out and observe. I really always enjoy because, I'm someone who works a full-time job. So it was really nice in winter to be able to go out and then be able to get back home at a decent time. That's wonderful. Compared to summer where it really doesn't start getting dark out until 10, 11 p.m. And then it starts getting light again at 3 or 4 a.m. And those changes in light are really subtle, but they really do impact your visual observing. So it's really important to get as much full darkness as you can. So in winter, it's awesome that you can just be out and you can be ready to go and observe at like 7, 8 p.m. That's awesome. So yeah, earlier sunset, later sunrise. And something I also really enjoy is just the if you can stand it, obviously, but the peace and quiet of winter nature. I don't know. I like when I'm out at the observatory and I'm just looking out and it's very cold and, quiet out and everything. It's really nice. So, it's a beautiful chance to get out and observe the winter weather. We're kind of stuck here in Western New York, so might as well enjoy it. And obviously, as always, there's just a lot you can see in the wintertime. There's some beautiful open clusters, which I'll get to later. I always really like observing the clusters. The deep sky objects, obviously, we'll go over the Orion Nebula, everyone's favorite. And some winter galaxies that are really fun when you get into the springtime observing that you can get out and see. And then our cons. The biggest one, obviously, the cold. I'll say it again. It's been a very cold winter. I have not, in all honesty, I have not been out on some of the very, very cold nights. So, even I am not brave enough for that. When you get the wind chill under -degrees, it's a little too much for me. But, it's still, despite that, yeah, it is a little bit of a con. Your mirrors for your telescope can ice over. You get your cold hands. It's not fun. So, all that is stuff you have to kind of keep aware of. And then around here, our cloudiest months are November through February. So that is obviously, you kind of have to take what you can get. And then, planning that around new moon, obviously, so you don't have the moon and you're observing. Though, of course, you can do some wonderful winter lunar observing. But yeah, definitely take what you can get around here, in this cloudy place of the world. And then there's always kind of like managing your stuff, hauling out all of your clothes, getting dressed, taking it all with you, your heaters. If you heat your telescope with a battery, you kind of have to be aware of that kind of stuff. So just things to keep in mind, challenges, but don't necessarily let these challenges stop you. So here's some tips, and there's a lovely image on the right here that I really, really enjoy. I always love finding images for the presentations because this gentleman is out here with this nice Dobsonian telescope. You can actually see this is the Orion constellation here, and the Orion Nebula is actually right there. So I think that's all cool. But anyway, but yeah, the top stuff, you know, just stay warm. Layering is really, really important. One of these winters, I'm gonna finally get one of those really nice, you know, down full jackets that they have. But right now I just wear a lot of layers, ton of sweaters. I'm a big sweater person. I have a closet full of sweaters. And then obviously, you know, gloves, hat, scarf, all that. Don't forget any of that. It's really, really important. It's, you know, even I actually do have like a checklist that I make, you know, just to make sure I don't forget anything. You know, keep your extremities warm. Like I said, gloves, hat, scarf. Hand and foot warmers are big. I bring those out with me all the time. I have the foot warmers, I have the toe warmers. You know, I got them everywhere. They're really important just to, because, you know, you're standing still. Sometimes with movement, you can kind of keep yourself warm, but, you know, especially when you're just standing still trying to observe stuff, it can really start to get to you. And take warm drinks, you know, any kind of drink, as long as it's warm. Coffee, obviously, and hot chocolate or cider or something. And, you know, take breaks, especially if you're a BAA member. You know, you can be at the observatory. You can go back in the warming room. You can kind of warm up a little bit, talk to people, and then go back out. You know, don't let the cold stop you, but also don't, you know, put yourself out there. There'll always be another night, and there might even be a warmer night. So, you know, don't stay out there and be miserable just if it's, you know, a little bit cold. And then dew management. I say dew management, it's kind of moisture management because, you know, once you start to get below freezing, it's going to be frost management. But you know, just keeping your telescope mirrors, your secondary and your primary mirror, keeping them warm. I usually have a hair dryer that kind of blasts, you know, the warm air on the mirrors. And then I also have an image here of a dew strip, which are kind of like heated pads. You know, you see these a lot on all sorts of telescopes. And you can, you know, put them on your mirrors there and kind of keep stuff warm. You can make them yourself, which is kind of a fun DIY project. It does involve some electrical work. So, you know, if that doesn't sound fun to you, kind of playing with wire and getting that all connected. So but you can purchase them as well. But you know, definitely recommend those for kind of keeping your telescope, keeping the frost off it. So so yeah, those are just some things. I mean, it really is just kind of just keep a good attitude sort of, and, you know, stay practical and stay warm. But I also wanted to show some differences. So, you know, you might be asking yourself, why even bother? You know, why do you go out in the winter? What is it worth it? Well, obviously, you know, as everyone knows, over the year, our Milky Way, our view of the sky changes. And I wanted to show the differences between the summer versus the winter sky. So actually, these are two images, both from the Stellarium astronomy software. Both are in the exact same position, and they're looking south at 11:30 p.m. So this is, you know, this would be in July here. And you can see we've got Sagittarius here, we've got, you know, Scorpius, all the beautiful regions of the sky that we love, and all the deep, you know, deep sky objects. And then this is actually the same one, but in winter. I took this, so this would be kind of December, so, you know, really the depth of winter, but this would be very, very similar view even today in February. And you can see that the you know, it's completely shifted. It's almost like a mirror image. It's flipped around. And you can also see that there's kind of more color in the left-hand one. A little less going on over here, which I will explain why in a moment. But you know, despite the difference, you know, obviously completely different constellations here. But despite that difference, we still do get many beautiful deep sky objects. But yeah, that's, you know, I don't know, I always like to kind of, even though the summer Milky Way is kind of like a favorite object of mine, and I love the looking and seeing the whole, you know, the whole variety of objects. The winter Milky Way, you know, as you call it, or the view of the Milky Way is still beautiful in the winter. So one of those like subtle beauty of it is really nice. But why is it different? I will explain why with this lovely diagram. It's not to scale, as you can see. And this is an artist's interpretation, so this is not, you know, not an actual image, but I wanted to show off the fact that in the summer, as you can see, here's our little summer view. So we are looking into the center of the galaxy, the center of our Milky Way. So, you know, we're seeing more objects simply because we're looking across more stuff. And then due to the rotation of the Earth, you know, over the year, the Earth, we are looking out at a different portion of the Milky Way in the winter. So that is why there's just less stuff. You're kind of seeing less stuff. But I still think it's beautiful. All these, again, this is an artist's interpretation, so it's not what it actually seems like, but you can kind of see that the beautiful arms. There's actually, we do have names, I believe. Where the sun and the earth is in this image is by the Orion spur, I believe it's called. So each arm of the Milky Way, we kind of have named it and mapped it out a little bit. But yeah, I think that's amazing, just the difference, how it changes throughout the year, and how we literally are looking at the Milky Way. I was never forget that. So yeah, I just thought that was mighty cool. And now I also wanted to talk about some specifics in the winter sky. So this is a very complicated. I got to put a lot of stuff into this, but as you can tell, so we'll start here by maybe looking in the center. So we have these green lines. So this is what's called the winter hexagon. Because the very bright stars of some of the primary winter constellations form a hexagon. It's like the companion of the summer triangle, which you might have heard of in my summer presentation. So we have, some beautiful, we have the Orion. Betelgeuse is for some reason misspelled in this one. Don't know why, but that is Betelgeuse, not Betelgeuse. But so we have the Orion constellation, we have Canis Major down at the bottom left down there. We have Sirius, which is the brightest star in the sky. Rigel, Aldebaran, Capella, Pollux, Procyon, those are the 6 stars here forming the hexagon. We have the Gemini constellation up there, Auriga, so many, and these are all kind of the primary winter constellations. And so I have some images on the left hand and the right hand side here of just some objects that I really like. I think the Rosette Nebula, really beautiful. This is kind of more of a photographic, showpiece when you observe it. Unfortunately, you cannot see those beautiful pink colors that it has, but I always love when fellow BAA members show off their images, because then I get to see the beautiful colors. And that is located over in Monoceros here, so kind of in the left hand side of our central image. And I also wanted to highlight Sirius A and B. So Sirius, like I just said, the brightest star in our sky, but what you didn't know is it is actually a double star. And it, in this picture, you might be able to see it's at the bottom left here. So you can see, our very, very bright Sirius A, our primary star. And if you might need to kind of lean in close, get close to your computer there, but there is a very tiny other dot down there. And so that is actually Sirius B. But it's very, very hard to see this. It's incredibly hard because, you're looking at the brightest star in the sky here, compare that to the very small companion star. So it's a challenge to observe. But if you can split that, it's very cool. So I have this image. This is taken by NASA, obviously, so they have all the good equipment. You can see, yeah, I don't know. I always think that's really neat that it is a double star, but it's also the brightest star in the sky. So that's fun. And then up at the top right here, I have some beautiful clusters that I've highlighted. Like I said, I really like the clusters. We have M37, M36, and M38. And those are actually all located by the Auriga region. So I kind of put them next to where they actually are in the constellation. And those are really fun. I don't know, observing them is always fun for me. I just love what do they say? The glass on velvet, the crushed glass on velvet, or the rice on velvet. So that's always a beautiful view. And then the Pleiades, I've kind of highlighted that because you can actually see that visually in the main image here. That's another, technically, I believe that also is an open cluster itself. So, another cluster, but a very big one. And that one's beautiful in binoculars. And you can see in our image here, we have all sorts of beautiful nebulosity, which is really nice. And the Hyades too, it's right next to there, Taurus, the bull. So yeah, those are kind of that's kind of the big picture view. Obviously if you were at this with a telescope, it would be a little bit different, but those are some lovely standout objects that I always like to observe. And then obviously you can't do a presentation on winter observing without mentioning the Orion Nebula. M42, the classic. I mean, you can see this in any telescope. You don't need a big telescope for this. I mean, this is really, like I've observed this in small telescopes and big ones, and it's always a treat. We have a beautiful image, on the left over here, taken by, an astronomer, and you can kind of, observing is always different from pictures. You see the picture, it's different from what your eyes actually see. But, the Orion Nebula really is one of those objects that you can see so much of the dust and the stars and, all those beautiful, subtle differences with your own eyes. And then I also wanted to highlight on the right-hand side here, a fact that I always really like to think about is the fact that we have a sketch on the right-hand side. This was done by a gentleman. I apologize in advance. Etienne Leopold Trovelot. I think he's French. But I think that's really cool that he made this on I believe, a 26-inch refractor at the U.S. Naval Observatory, and he, just looked at this with this big refractor and then drew it. And I don't know, it's 1875. We've been looking at stuff for hundreds of years, and I always love highlighting the astronomy sketches because I think that's really cool piece of history. And this gentleman apparently made over 7,000 astronomy drawings over his lifetime, so he was just out there. Dream job, honestly. If I was good at astronomy sketching, definitely. But I don't know. I always think that's cool, and you can kind of see some of the same objects in the actual image, and then compare that to the sketch there. So I think that's always very cool to see. Just a little bit more here. I just wanted to show off some other winter, and these are actually almost springtime constellations. And obviously we're in February, so we're kind of moving into the spring here. The first one up is Leo. So Leo, the lion, this is a great constellation if you like galaxies. It's been said, springtime is galaxy season for astronomy. So, we're kind of moving. We have Leo, we have Virgo coming in, starting to show up there. So that one's kind of a later, this time of night. I think you'd probably get it maybe around midnight or so. It'd be really well placed. And I actually have down at the bottom right here, we have M65, M66, and NGC 3628, which is called the Leo triplet. So those are really fun. This is a lovely image too. They've got a whole slew of galaxies, and they're all kind of different shapes and sizes there. That's a fun one in a telescope. You would kind of need maybe a larger telescope for that, a larger instrument, because you kind of get into the faint blobby galaxy kind of look there. But that can be fun as well. And then, Ursa Major, Ursa Minor, the Big and Little Dipper. These are better placed, I believe, later on in the night. They actually get a bit better in the winter. And these are actually constellations that you can see any time of the year. But because they're circumpolar, so they move around Polaris, the North Star. So it's always rotating around that North Star. But some times of the year, it's better placed than other times to see the various galaxies. It's got the Cigar Galaxy, Bode's Nebula, M101, beautiful, beautiful galaxies up there. Again, you do kind of need a larger instrument for that, but those are some of my favorites. And then Draco, Draco's another one that is circumpolar, so it moves around the North Star. And I have this lovely image of the Cat's Eye Galaxy, which is another beautiful one. Sometimes it's stuff that you can see a little better with your eyes, and sometimes it's just images. I'm like, oh, I really like that. But another beautiful one. And actually up here, M1, this is the Crab Nebula. This is actually in Taurus, the bull. So this one's a fun one with the telescope, and it's also the first Messier object. And then just one more, Cassiopeia. It's very high at the beginning of the winter nights. So if you went out, you could probably pick out some objects that are really fun at the start of your session. But yeah, it's got some beautiful star clusters, double cluster, all that fun stuff. And it's also fun for imaging. I should have put some pictures actually, but it's got some beautiful, the dual heart and the soul nebulae. Those are really fun. And, but yeah, so I guess that's all I got for now. But I would say, while we still have the beautiful winter weather left, get out there if you can and enjoy winter observing, but stay practical, stay safe, stay warm. There will always be another winter, so don't worry. I always try to keep that in mind. There's always going to be another night. So, if it's not the best night or the clouds or it's too cold or something, you can always do another day. But those are just some of my favorite objects. I hope you can get out and observe them with no matter what instrument you have. And I will send it back to you, Dennis.
Wow, thank you very much, Emily Ann. That was outstanding. Just a tremendous presentation. It made me want to go out and get my hat to go out observing. I did.
Feel comfortable.
See? Nice, wonderful hat for doing my visual observing, most definitely. And so Lalani said, well, just a great presentation. And Kathy says, wow, she didn't know that. So that was really, really fantastic. So what we're going to do next is, again, I thank you for joining us, and thank you for help us spread the word about astronomy and keep looking up. And we do a lot of wonderful things out at our observatory as we keep looking up, and we do need your assistance if you're able to. Yes, I'm asking for donations. You can help us by going over to the Buffalo Astronomical Association's website, and you can join our group. You can submit a donation. You can go to the Penn Dixie Nature and Fossil Park and join them or send them a donation. And you can also go to the Buffalo Museum of Science and join them and actually donate and see some of their programs as well. So any little bit really does help us out. Yes, you too can help us spread the news and of astronomy and all the great, wonderful things out there. And, you know, it really helps things bring it to a point. So what I'm going to do before I bring up our next presentation for you is actually take you over to Dan Marcus, who's going to share something from our observatory. It kind of, well, marks the spot, I think. Dan, take it away.
Yeah, well, Emily Ann likes to do it outside in the cold. I like to do it inside where it's warm. And the observatory is a really good place for that. We have a nice warming room. The camera goes out where it's cold. And X does mark the spot. There's a lot of satellites out there. And I couldn't have planned this shot better if I tried. We had 2 satellites go right through it. And this is the Owl Nebula in the Big Dipper Bowl. It's really pretty. If you come out and look at it through our 20-inch telescope, it does kind of look like an owl's face if you look at it. This is just one single frame, and it just happened to catch 2 satellites roaming through it. We do have a little better shot of it. This is what it looks like with a little more exposure to it. You can actually make out there's another nebulosity hunk down here, not part of this particular one. This happens to be a dying star. This happens to be the central star that exploded and kind of burped this outer gas shell. We can actually get a lot of data. We can actually sit on an object for several hours before midnight, and I can actually make it home before 1 o'clock in the morning. So winter's nice, and with the heat, it is wonderful. And with that, I'll pass it back on to Dennis.
Oh, why, thank you very much, Dan. That was really an outstanding presentation. Certainly the Beaver Meadow Observatory is a wonderful place to observe the night skies. And of course, there are lots of technical things that happen out there and stuff that help us deal with certain things. So any donations you can provide to any one of the groups here coordinating certainly is helpful. Of course, the folks over at NASA have launched one of the most exciting telescopes available. It's an engineering marvel, an engineering feat, and they actually got their first image. Well, 18 images, because they do have to focus their telescope. Yes, it's very cold out there in space, and yes, they do have to focus their telescope. So I'm going to pass it off to our director, Gene, who is going to play for us the James Webb Space Telescope video update from NASA. Take it away there, Gene.
And we evaluated whether the camera was working well enough for us to proceed on with the alignment. And as we analyzed those first, photons, if you will, the team was pretty positive that the camera was working properly and the instrument was working properly. So we picked a star that was very bright and didn't have any stars near it that would contaminate the image. We know that the primary mirror segments aren't aligned, so they actually act like 18 separate telescopes, and we expect to see 18 separate images, one for each mirror, that are a little bit blurry at this point because we haven't aligned or focused anything. And so we pointed at a bright star, and we made a mosaic. We actually took the near-infrared camera and we took images in different parts of the sky, and then we looked for the 18 spots from the 18 different telescopes, if you will. And we were very excited to find them. And the 18 spots were actually fairly close to each other. So really everything was very close to what was predicted. We've identified which of the 18 spots is which mirror. At this point, we even know which ones are from the wings. And it turns out one of the wings, you can actually see those 3 spots are a little farther over. And that's sort of what we expected. So we've identified all 18 spots, and the next step is to make an array of them. And then we're ready to start what we call global alignment, which is when each of those 18 spots will start to be aligned and focused. And that's sort of the last step before we take those 18 spots and put them on top of each other to start forming a single star going through the 18 separate telescopes. That's the work that will be starting soon. We also took a selfie of the primary mirror. We took an image of the primary mirror, and that helps us understand the alignment of the telescope, especially the primary mirror, to the camera itself and the instruments. There's actually a special lens in the near-infrared camera that you can put in, and it allows you to take a picture of the primary mirror itself. And in this particular case, one of the segments is pointing at a star, so that is the segment that lights up. But you can see the outline through the shadows of all 18 segments, and you also can see the outline of what's inside of the instrument itself, and we can see how well that primary mirror in the telescope is aligned to the instrument. And that gives us some initial confidence that the alignment looks good, and that's a good starting point for doing the alignment of the telescope. We have now gotten some data looking through focus, and we've been able to see that we don't see any surprises in the shapes of the mirrors that we're looking at. So far so good, but we do have a long way to go.
Well, that was an outstanding presentation from the folks over at the James Webb Telescope. Yes, I really do thank them for sharing that information with us. And certainly we can go ahead and check out the folks at NASA and keep up with the James Webb Space Telescope. It certainly is exciting. We're going to say hi to Donald over there on Facebook, and certainly some really cool things that are happening. Of course, there are all kinds of terms and terminology that they bring forth, and they tell us about some of those details. And of course, as we're looking up, you need to know a little bit more about some of those lesser known astronomy terms. And that's what we're here to do. We're here to kind of educate you and share those things with you. So right now, I'm going to pass this off to Paul Moretti, who's going to talk to you about some specialized and lesser known astronomy terms. Paul, take it away.
Thanks, Dennis. Today, I just realized this a little while ago, we're more than about halfway through the winter season, which is kind of nice, which means hopefully the weather will start getting a little bit better out. And more and more of us may venture outside to gaze into the night sky. And because of that, I wanted to go over some terms. This presentation is for the beginning astronomer who maybe never was exposed to these terms, as well as the more seasoned astronomer like myself, who maybe hasn't seen these terms in a while, and it's a nice refresher, or maybe you just remember something you haven't gotten to before. So with that in mind, Emily Ann and Dan really concentrated on deep sky objects, and a good portion of this presentation is, as a planetary geologist, I concentrate more on things on our solar system. So many of the terms you're going to see here are more germane to celestial objects in our solar system. So why don't we hit right to it? Okay. Okay, some basic terminology. I broke it down into 3 layers, and we're going to talk about 2 of these 3 today. The basic terms for our equipment, and then terms that define an individual celestial object. Now, there are some terms that can decide the object's position or its geography in the night sky, but we're not going to get to those tonight, I don't think. So basic equipment, I'm going to blow through this very quickly. It's just the types of telescopes we have. We have refractors, which collect the light using lenses, reflectors, which collect the light mainly with primary mirrors, and of course compounds, which are a combination of the 2. And we have more than one way to mount our telescopes. It could be an azimuth mount, as you can see from the little image there. And this is based upon being parallel and perpendicular to the Earth's surface. It's very, very basic. And you need to really know your location every time you're trying to look some things up. The other one, of course, is equatorial. And this is predicated on your latitude. And as you can see, this telescope has been placed at a latitude very similar to what we may find here in the Buffalo area. The nice thing about this is it makes it a little bit easier for us to use coordinates, general coordinates, to find objects. So the 2 terms that we use for this, of course, are right ascension and declination. And the right ascension is, of course, both of these are measured in hours, minutes, and seconds. And it's sort of like longitude on Earth, whereas the declination is very similar to our latitude. And these are our specific locations that everything is measured off of, where declination 90 degrees is the North Pole. And that's how we use these. And once you have everything, your telescope set to the latitude that you're at, the general coordinates will always take you to the right location for every object. Now, these are some of the terms that we're going to talk about today. As you can see, there's quite a few of them there, and some of them are a little more relative to regular astronomy, and other ones are more specific to individual objects in our solar system. So let's talk about magnitude, because this is the first thing you notice when you look in the night sky. Not every star is the same brightness or the same size. And this boils down to what we call apparent magnitude and absolute magnitude. Now, the apparent magnitude is how the star appears, from the Earth right now. We look up in the sky, and they appear to be different brightnesses. I think Emily Ann said that Sirius is about the brightest star in our night sky, as opposed to other things that are not quite as bright. And this is really a function of distance, but as well as stellar mass, diameter, fusion reaction intensity, whole host of things. But then there's what we call absolute magnitude. Now, that's actually the brightness of a star measured from a set distance, which is 10 parsecs or 32.6 light years. And if we could put every star in the night sky or every celestial object in the night sky at that distance, the brightness we would measure there would be its absolute magnitude. This is just something to kind of help us understand it. You can see we're on the far left, you can see the Earth and our sun. And our sun is incredibly close. It's only 93 million miles away from the sun. It's one solar diameter, one solar mass. Its absolute magnitude is 4.83, pretty dim. But its apparent magnitude, because it's so close to the Earth, is minus 26.47. That's incredible. It's a G star, which means its surface temperature is about 5,700 degrees Kelvin. We look all the way to the far right, well, we see Betelgeuse. Now, it's pretty far away. It's over 600 light years away, and it's like more than 800, almost 900 solar diameters. The thing is huge. It's a beast. It's more than 12 times the solar mass. And as you can see, its absolute magnitude is minus 5.8, incredibly bright. But its absolute magnitude is minus 4.05. So it's still pretty bright, and that's because it is humongous. Even though it's an M star, which means it's red a red supergiant, and its surface temperatures are only 3,500 degrees. So that's where distance really plays a big role, but so does the mass of the star. So what I did here is I went to Stellarium, which is a site on the internet that you can go to, and I downloaded what the sun would look like from 3 locations in our solar system. To the far left, if we were at Mars, that's what the sun would look like from about 140 million miles away. We went all the way out to Saturn, which is almost 900 million miles away, gets much, much smaller. But out where Pluto is just under 3 billion miles away, look at how teeny tiny it is. And that's because, it's not a big bright star, but because we're so close to it, it burns bright in our daytime sky. Now, I'm going to talk very briefly about zenith, because you hear this term, and it's the highest point in the sky that a celestial object can reach, and it can change from time to time. But the opposite of that, well, not the opposite, but the other thing we talk about quite often is the ecliptic. And this basically is the orbital plane of the sun. Think about the sun rotating, and from there outward goes this big old plane, and everything is going to get managed and measured off of that plane. Now here we're talking about orbital inclination. And this is going to get a little here. The angle a celestial body creates between its orbital plane and the orbital plane of the body it revolves around. Well, I'm glad we cleared that up, huh? So this is basically what we're talking about. The pink oval there would be the ecliptic in the skewed viewpoint. But look at the blue one and the yellow one. They're kind of off a little bit and exaggerated to show this. And that would be the orbital inclination, or how many degrees we're off from that ecliptic or that orbital plane of the sun. Okay, and as you can see here, the Earth is pretty much on plane. It's really got a very, very small deviation. Jupiter's off about 1.3 degrees, and Saturn is off 2.49 degrees. And this, along with a couple other things, helps us see different views of different planets. Like Saturn, sometimes we see the rings wide open. Sometimes they're very close, and part of it has to do with the orbital inclination, and part of it has to do with another term coming up called obliquity. Now, obliquity is the tilt or angle of rotation of a body away from the perpendicular to an orbital path plane. Yikes. But what we're talking about here is what's the tilt from perfectly up and down. The Earth has an obliquity of 23.4 degrees, and that's why we get our seasons, as a matter of fact. From this image here, you can see that 23.4 degree tilt. And in the summertime, in the Northern Hemisphere, we're tilted towards the sun, so we get a greater concentration of sun in the Northern Hemisphere. And in the wintertime, it's the opposite, and we have less. And that's part of the reason, most of the reason why we get the seasons. And as you see here from this image, as the Earth goes around the sun, that obliquity stays the same as it goes around. And as I said, on the far left would be like summertime in the Northern Hemisphere, and the far right would be, of course, wintertime in the summer, and in the Northern Hemisphere. Precession. This is our next term. This is the circular rotation motion of, well, some of these are really crazy. Circular rotation motion of the rotation or oblique axial plane over time. It's like a spinning coin or a top, or even a gyroscope. I don't know if you can see the little image we have here, but this is actually a little toy gyroscope that I have. And if you've ever like taken a coin and spun it on a table, and you see it kind of spinning around, that spinning is the rotation. The tilt that the coin sometimes has, or even a top, that's its obliquity. And that little circle that tilt makes, that's its precession. So that's what those three terms reference. And you can kind of see it here in this image where I put, how over a long, long period of time, as you can see here, 13,000 years, the actual tilt of the Earth is going to be facing in a different direction. Right now, the North Pole faces towards Polaris, but in 13,000 years, if you look all the way over here to the left, it's actually going to, the North Pole will be pointing towards the star Vega. Totally different. And again, another 13,000 years after that, it's going to go back and it's going to aim towards Polaris again. All right, one of the last terms I want to talk about is called eccentricity. And this is basically the ovalness of an orbit. Now, everybody thinks that these planets and all these bodies that go around the sun are in perfect circles, but they're not. And below here, I just have what, if E was 0, that would be a circular orbit. If E is between 0 and 1, it's an elliptical orbit. If it's equal to 1, it's basically parabolic trajectory, which means it's not an orbit. It's coming in and going out on a parabola. And of course, if E is greater than 1, it's even hyperbolic. It's even more crazier, but it's just kind of passing through. And this is what we're talking about. If you see the sun in the center there, the yellow circle, which is really not a circle, it is slightly off, could be like maybe what the Earth is, fairly round, but not exactly. And think of the green oval more like, I don't know, like Halley's Comet, for example, which has it's really eccentric. It comes in very close to the sun and goes way out, I think, past Neptune. And it travels at different speeds depending on how close to the sun it is. But this is a high eccentricity. So I think at this point, I'm going to stop. We have more terms to go over, which are more about where objects are compared to other objects in the sky. For example, like conjunctions and oppositions, but we'll save that for another day. And at this point, I think what I'd like to do is turn this back over to Dennis.
Why, thank you very much, Paul. That was an outstanding presentation. Those was a great way of introducing some folks into astronomy and some of the terms in astronomy and some of the information that I didn't even know about. So very much thank you for that. Really, really fantastic. And of course, we'll be looking towards our next presentation. Yes, we'll be looking up again in March. We don't want to go too mad about that, but we'll be looking forward to the end of that presentation and some other terms that will be fantastic. And of course, winter observing. Winter observing is always tremendously fun. And I'm going to go ahead and I'm going to be sharing with you a photo that I took out at Beaver Meadow in 2018. And of course, we've talked about this a lot this evening, but this is the Orion Nebula. Yes, I use electronically assisted astronomy, or I take pictures of deep sky objects and process them, but I was able to capture a fantastic shot of the Orion Nebula and even able to resolve the 4 stars here in the trapezium. Yes, this was a wonderful night out at Beaver Meadow. And yes, Beaver Meadow will be hosting live events coming again here in April and May for you. We're going to be trying to do those from April to October. So keep a lookout and we will be informing you, of course. But to lead us into that, I'm going to go ahead and stop my sharing, and so that I can pass you off to our observatory director, who is in charge of putting things together at the observatory and, of course, sharing some wonderful images. Dan Marcus, why don't you go ahead and take it away and tell us what you have?
Yeah. Well, we were out there about a month ago. We happened to have a really clear night. Dennis encouraged us to stand on an object for several hours. This happens to be the Crab Nebula. The ancient Chinese, I think, was somewhere 1080 something, I think. I actually saw the central star in this one that blew up. I'm assuming that we can see my screen. I see my circle of death from my mouse pointer, so I don't know quite what's going on with my computer. But it's fun to look at it with the 20-inch out in the back pad in the wintertime. If you're really brave and daring like Emily Ann, she gets a really nice view of that in the 20-inch. I cheat again. I sit in a nice warm room and put a camera on and do my electronic astronomy. I just find it more comfortable. Now we'll see if my, okay. And one of the other things that we managed to catch is, this is in mononucleosis. Yeah, I'm gonna pronounce it properly, in mono. This is Hubble's Variable Nebula, which happens to be again in the winter sky, and it's fairly high. This nebula right here is, this star is embedded in this big gas cloud that probably coalesced to form that young hot star. And this star happens to have a massive dust that orbits around it. When it orbits around the star, it blocks off the starlight. And the starlight is what illuminates this nebula. So this nebula actually changes shape over the course of the year. So it's not always the same. This is our first image that we've taken of it this year. I'll be back again next year. We'll take a picture again next year and we'll see how much it's changed. So this is one of these things that you should be able to photograph from year to year and actually see something different in it. So it makes it a little more exciting to me. I mean, you got something that stays put in the sky, it's not as much fun. But if it changes from night to night or from year to year, it's kind of interesting to watch it and see what's going on with it. So those are the most recent images we've taken out of Beaver Meadow. These were taken with our C14 telescope. That's a 14-inch diameter telescope. It's fairly powerful. It works pretty well for photographing galaxies and small nebula. Our smaller MP101 is a smaller 4-inch refractor, good for looking at planets as well. But it also gives you a much wider field of view. I don't have any images with that right now. We're still working on processing those. So with that, hopefully we'll get a few more clear nights before the lake starts to defrost and we start getting some clouds again. And then spring will be here, and then hopefully we'll be all back out at Beaver Meadow where we can actually enjoy doing astronomy with each other. So let's hope things get better. And with that, I'll pass it back to Dennis.
All right. Well, thank you very much, Dan. That was really outstanding. And we have some really great images that we can present to you. It's great to see visually through a telescope, as well as using electronic assistance and taking images with cameras and such, because the camera can capture a little bit more than your eye can. And it certainly is outstanding and a lot of fun to do. And we love spreading that fun and that joy to everyone out there. And so I'm going to share with you just a couple more of my photos before we wrap it up this evening. And we really do appreciate you out there to joining us and spending a little bit of time on this very, very busy weekend as you prepare for your Super Bowl parties and get-togethers, as well as, well, if you forgot Valentine's Day, you better get out there and take a look. But what I'm sharing with you now, that's the Orion Nebula. Again, these images were taken at Beaver Meadow, but there's also something nearby called the Horsehead and the Flame Nebula. Yes, this does look like a horse's head to me too, but we're able to capture some great detail, and because we have some very, very dark skies out there, and we can only be out there and do these things and share these things with you if you are helping us support us, because we are a 501c3. Yes, we do this. We are volunteers, but there is maintenance that needs to be done out there, and there are telescopes that need to be kept up. And so any little bit that you can provide certainly helps us out. Of course, this one right here, one of my favorite images from Beaver Meadow, the Pleiades. This one to me looks like a little bit of an angel, and certainly was able to get some great detail, some great nebulosity, some great wisps, and some great color. We're able to do all of these things out at Beaver Meadow Observatory. And if you join us and help us help you, we can share the love that we have of our astronomy. And I'm stopping my share there for you, kind of doing two things at once. It sometimes can be a little bit confusing, but we're able to do a lot of wonderful things and get into the science with you. We're able to get into the very pretty pictures and the art with you, also the engineering and even the math. And so we're a very varied group of individuals who are just excited by astronomy. And I really have to thank Paul and Dan and Emily Ann and Holly for joining us this evening and spreading this wonderful event to you. And as we start to get a little bit warmer here, come March 12th, yes, you heard me, March 12th, we will be doing this again. And we won't be live at the observatory unless we have some clear skies, but we don't want to go a little mad yet. Oh, yeah, wait, March Madness? Oh, wait, for us, it's March Messier Marathon Madness. Yes, we did that for you last year, a Messier Marathon. What is that? Well, to find out, you're going to have to join us next month. But until then, I want to thank you, and I want to remind you to keep looking up.